My name is Muhammad Syamil Irfan bin Hairil Anwar. My matric number is B132310488. I will present about OGPV, off-grid photovoltaic system. I will present about introduction, system component, schematic diagram, and policy. Introduction. Off-grid photovoltaic systems are independent solar energy systems that do not rely on the national electricity grid. These systems are very useful in remote areas where grid connection is difficult or expensive. For system components, we have four main system components. Firstly, solar to capture sunlight and convert to DC electricity. 2. Battery storage to store energy for use day and night. 3. Change controller to regulate power flow to batteries. And lastly, inverter converts DC to AC for home appliance. Schematic diagram. The figure shows the basic configuration of an off-grid photovoltaic system. First, the solar panel converts sunlight into DC electricity. The storage controller regulates the charging process and protects the battery. The battery banks store energy for use during nighttime or cloudy conditions. Then, the standalone inverter converts DC electricity into AC electricity for household appliances. The system also includes a low voltage disconnect to protect the battery from excessive discharge, while the generator backup provides additional power during low solar energy condition. Policy of OGPV. Off-grid photovoltaic system in Malaysia started mainly as rural electrification projects before 2005. The estimated off-grid solar capacity reached around 5 to 6 megawatt in 2006 and has continued growing through rural microgrid and hybrid battery system, especially in Sabah and Sarawak. However, exact yearly installation data remains limited because many off-grid systems are not officially recorded under national grid programs.
My name is Muhammad Adif Farhan. In this slide, I will explain the current issue of off-grid photovoltaic system or OGPV. One of the main issues is limited electricity access in rural and remote areas. Some villages still do not have stable electricity supply because it is difficult and expensive to connect them to national grid. Another issue is the high dependency on diesel generators. Diesel generators require full and regular maintenance, which increase operating costs. Besides that, fuel prices are also increasing, cause higher energy expenses for remote communities. There is also the problem of unstable power supply in certain remote regions, especially during bad weather conditions. Lastly, fossil fuel usage contribute to environmental pollution and carbon emission, which can negatively affect environment. I will discuss the challenge of off-grid PV system. The first challenge is the high initial installation cost. That system requires solar panels, battery, inverter, and other components, which can be expensive. Another challenge is battery maintenance and replacement. Batteries have limited lifespan and need proper maintenance to ensure good performance. Off-grid systems are also highly dependent on weather conditions during cloudy or rainy days. Solar energy generation become lower. In addition, energy storage limitation can affect the electricity supply, especially at night or during long period without sunlight. Finally, technical maintenance is required to keep the system operating efficiently. Besides the challenge of grid PV system also provide many advantages. First, it offers energy independence because users can generate their own electricity without relying on the utility grid. Second, there is no monthly electricity bill since the energy comes directly from sunlight. Off-grid systems are also very suitable for remote locations where grid connection is difficult. Besides that, the solar energy environmentally friendly because it reduces pollution and carbon emission. However, there are also some disadvantages of grid PV system. The main disadvantage is the expensive upfront cost for installation battery system. Battery lifespan is also limited, so replacement is needed after several years of use. In addition, the system requires regular maintenance to ensure all components function properly. Another disadvantage is limited energy production during low sunlight conditions such as rainy weather. Lastly, expanding the system in the future can also be costly because additional panels and batteries may be required. This is all from me. Thank you.
Okay, hello everyone. My name is Danakumaran Analaki Kalasevan. My entry number is B1323100635. So now I will explain the facts and figures of off-grid photovoltaic systems in Malaysia. Off-grid PV systems are mainly used in remote areas like Sabah and Sarawak where grid electricity is difficult to access. Before 2005, most solar systems in Malaysia were small off-grid systems for rural electrification. Over time, the government expanded solar projects to remove the remote villages and islands. By 2025, Malaysia's total solar capacity reached about 5,777 megawatts, showing rapid growth in renewable energy development. Overall, this shows that off-grid PV systems are becoming increasingly important for sustainable electricity supply. For this slide, I will explain the previous development of off-grid photovoltaic systems. Earlier, off-grid systems mainly used lead-acid batteries, which had lower efficiency and required frequent maintenance. The systems were mostly used for small-scale applications such as lighting and basic electricity in rural homes. In addition, solar panels at that time had lower efficiency and the overall installation cost was very high. Although the technology was limited, it helped develop the foundation for today's modern solar system. Now, I will explain the current development of off-grid photovoltaic system. Today, lithium-ion batteries are widely used because they are more efficient, longer lasting, and require less maintenance compared to older batteries. Solar panels are also more efficient, while smart monitoring systems allow users to monitor energy usage through mobile apps and Wi-Fi. Hybrid systems combining solar panels, batteries and generators are also becoming more popular for stable electricity supply. Overall, these developments make off-grid PV systems more reliable and suitable for future renewable energy applications. That's all from me. Thank you very much.
My name is Nur Fawiza Alia binti Muhammad Izzuddin and my matrix number is B1323100596. For the future of OGPV system, battery costs are expected to decrease further, making the system cheaper and more accessible. AI and smart energy management are also expected to improve system efficiency. In addition, future solar panels will become more efficient in generating electricity. OGPV systems are expected to support rural electrification and contribute to the global transition towards sustainable energy. Next, I will explain the current trends of off-grid photovoltaic or OGPV system. Nowadays, lithium-ion batteries are widely used because they are more efficient and have a longer lifespan. Smart monitoring systems using Wi-Fi and Bluetooth are also becoming more popular. Besides that, hybrid solar systems that combine solar panels, batteries and generators are increasingly adopted. The decreasing cost of solar panels and batteries also make OGPV system more affordable. The demand for off-grid system is growing, especially in rural and remote areas. Malaysia's solar capacity also surpassed 5.7 gigawatts in 2025 due to rapid renewable energy development. In conclusion, off-grid photovoltaic systems are an important solution for sustainable and independent electricity generation, especially in remote areas. Although there are challenges such as high initial cost and battery limitations, future technological advancements are expected to improve system performance and affordability. These are the references used in this presentation, including journals and online sources related to off-grid photovoltaic system and renewable energy. That's all from us. Thank you.